Hey guys, what's up and welcome to the Phil Studio. Today is a great day because I'm really excited because I managed to harvest free energy out of a piezo disc. Okay, to clear things out, well, there's no such things as free energy. I don't really know what it means, free energy. Well, recently in the past year, there has been a big trend with the term free energy, and like everyone went crazy doing some experiment and stuff, but I just don't get it. I don't get it. Like, free energy, is it when you plug yourself on your neighbor's outlet, power outlets, so you get free energy? Well, in this case, it would be stealing energy. Personally, free energy sounds like either it's bullshit or magic tricks. I don't know if you get it or you remember at school in your physics class, you may have learned something important, one of the most important physics law, and it's that nothing is created and nothing is destroyed, everything is transformed. And today I'm going to show you this. With this piezoelectric element, I'm going to generate energy. When I say generate, it's not coming from the world and it's not free energy. You will learn how I use my physical force or energy to generate electricity out of this piezo. And the best in this is that I can plug this on either a battery or a capacitor and charge it. So that's what you're gonna learn today. So there's no such things as free energy. Enjoy that. Okay, so we're on the bench, and if you want to follow on and create this project, which is energy generator out of a piezoelectric element, what you will need first is a breadboard. This will really ease the process of testing your circuit, and for sure a piezoelectric. The dimension doesn't really matter, but you should expect different voltage out of different kind of piezo. The medium one will just work perfectly. It's sturdy and old, so it's perfect for that. You will need a coffee and some other basic electronic components. I'll name them along the way while we build the circuit. So if you're following me for a while now, I'm sure that you know that piezoelectric can generate an audio signal when they are deformed or by the variation of pressure. This is not a surprise, I guess, because I've mentioned this thousands of times in my video, but I'll just measure the voltage it can generate when I gently hit the piezo. So I'm gonna measure the signal that we can generate. Oh, you see, this is like really high. It's a big signal. I'll go at 5 volt per division. I think we could like generate something like probably 10 volt or so, which is a lot of voltage, right? Would it be possible like to power up an LED simply by hitting on the piezo, right? Don't get me wrong, but if you want to try this experiment, take a 1 kilo ohm resistor, place it in series with the piezo, the red wire of the piezo, which is the positive signal. And if you don't know how a breadboard works, like, just mention it in the comment. This could be something interesting for a further video in the future. So, in series, we have the red wire of the piezo going into the 1 kilo ohm resistor, which goes into the positive leg of the LED, which is the long one, and then the negative leg of the LED goes to the black wire of the piezo. And if I'm lucky, Wow, nothing. What if I plug it directly? Okay, so we have a big nothing. So, can generate around 10 volt of pulsed signal, but cannot light a LED. Oh, that sucks. But like, is this because the frequency is too high and it's not long enough? I don't know. The pulse is not long enough to light up the LED. I'm not sure. So I'm gonna put something in series just before the resistor, and it is called a diode. The diode, if you don't know, is a semiconductor. Well, it's kind of complicated. There's a lot of application to a diode, but in our case, if I try to pass an AC signal in the diode, well, I'm just gonna keep either the positive edge of the signal or the negative edge of the signal, depending on the polarity of the diode. In our case, I just want to keep the positive edge of the signal. Oh my god, I think I can see a little spark. So, we're close to something. Currently it's working. Like, I can light up a tiny bit of this red LED every time I tap on the piezo. That's amazing, no? Well, not really, because I'm supposed to have a 10 volt signal and I cannot even light a LED. Well, I think maybe I could charge a capacitor. What do you think? I'm gonna try to charge this capacitor. Get rid of the LED for now. Okay, so make sure this capacitor is empty. You safely discharge a capacitor, just shorting the leg. No, this is not the safe way. If you have a big value resistor, you just put it in parallel with the two leg, and the capacitor should just discharge itself safely in your resistor. And I'm gonna verify the voltage. It's supposed to be empty, so okay, 0 point nothing. So I'm gonna put the red wire here on the negative leg of the capacitor, and each time I will hit, this should charge. Okay, I think we're discharging. Oh! 0.01, 0.02. So according to your concept of free energy, currently I think I'm generating free energy, but damn, it's so hard. Like, I have to push 100 times on that damn piezo to generate like 0.02 volt. Like, that's just impossible. I think there's something wrong in my circuit, no? I was thinking this circuit in terms of audio stuff. Like, you see how quickly I just plugged my black wire to the ground, because this is the negative and it should go to the ground to be shielded or just work properly, but this just doesn't make sense in our case, because I don't know if you've seen my video on how to create a dual polarity power supply. Well, I think this is a good video for you, but I'm currently, the problem is that I am trying to rectify an AC signal and AC pulse, but using only one diode, so I'm like half rectifying the signal. What we need is a full bridge rectifier. So what you're gonna need for that is 4-diode. You notice how I took this diode? It's a 1N4148. They are known as fast switching diode. So since we're working with something pretty high in frequency, I prefer to use this one, but the regular diode 1N4004 would work perfectly. You know, these little cool diode. But I try to reserve them and use them like most of the time in big power circuit. Since we're not working with big power, I'm gonna use 4 small 1N4148 fast switching diode. 1, 2, 3, 4. So for those who are really curious but don't know what the hell is a full bridge rectifier, well, a full bridge rectifier is a configuration of 4 diodes. The goal of this configuration is to have the AC input at each of these points, and at the output you should have always a nice and clean DC. In our case, it's gonna be pulses of DC. So we're gonna build that. The bridge here. Note that it's easy to mess up your bridge rectifier, but I have a little trick to make sure that I know where the negative pin of my diode is. It's always on this one, it's the black line. So I try to just align the black line to the cathode of the diode. The cathode is the negative and the anode is the positive. So let's go and build this. So this is what a full bridge rectifier would look like. If you don't want to like mess up with 4 diode, you can always find a full bridge rectifier looking like that. It's so easy to use. Here you have 2 legs for the AC signal, and it's identified here. You have a plus, your positive, and your negative. So this is a good way to make sure everything will work. Okay, so let's see this here. If I want to plug this correctly, my AC has to go there and there, which is there and there. Doesn't matter the polarity. That's something cool about a full bridge rectifier. It will ensure that the polarity of your circuit is always good. And I learned something like a while ago to protect like my homemade guitar pedal or stuff like that. You can always put a full bridge rectifier after the DC jack. So if someone come and just connect his power supply to the jack of your gadget, if you have full bridge rectifier, this will ensure that the polarity is always right. This is something really nice, but though you have to consider that you will have a little loss in the voltage, probably something like 1.4 volt. Okay, so the generator is plugged. Let's try to charge this big capacitor. I'm gonna use some breadboard stuff. So this should be the positive. There. Positive leg. And I'm gonna connect this to the negative rail here. And black wire here should be connected to the negative here. Boop. Okay. So we're gonna take the measure in the, I don't know, here goes nothing. So you see how now it's cranking up a little bit faster. We already have something like 400 millivolt with like 10 it. So I just crank up, I multiplied the voltage that I was able to generate because I'm using the negative edge and the positive edge of the signal. This is amazing. I think we have something now, like 0.7 volt, 0.7 volt, it's something like really good. 1.34 volt. You see the capacitor is slowly discharging in this resistor and in the LED. So what I'm gonna do is disconnect one leg of the LED, charge the capacitor again until I get something like 3 volt. So I'm gonna try that again. Okay, nice. You see this? You see that? You see this? You see that? Okay, we're at something like 5 volt. Each time I hit, instead of having like a weird pulses, I'm having like a big DC voltage that outputs. That's crazy. Maybe the capacitor is too big or is not big enough. I don't know. I'm gonna try with something else, okay? So here we have a big fat capacitor. It's 100 microfarad, 50 volt. Here goes nothing again. I guess I'll just try. Gonna check the charge. 0.5 volt. I'm gonna hit that repeatedly until we have a huge voltage. Gonna disconnect the LED. 0.6. So long. What now? 0.75. Okay, so my guess is that the design sucks a little bit and it's time to improve the circuit. We're gonna go with these big diode. Okay, so right here, plug this one. In this case, we'll see the gray part, the N, is the negative of the diode. We're gonna try a smaller capacitor. Something like 10 microfarad, 50 volt. Make sure it's at least 10 volt and higher because you don't want to explode your capacitor. Could happen. We're gonna try it now. I'm gonna charge this. Can you see? Here we have. Okay, it's discharging pretty fast, so we have to hurry up and charge it as quickly as possible. Oh my god, can you see that? 10! I was at 10 volt. Oh my god. I'm gonna close the circuit and release all the power in the LED. You're gonna see it light. Okay, close the light. Check that out. Oh! Was beautiful. Wow. The bigger the capacitor, the harder or the longer it is to charge it. That's my guess. Because I'm at 1.3. I think I need something like in between these two. Oh, I got plenty of stuff between 470 and 10 microfarad. I got something like 100 microfarad would do the job, I think. I hope it's gonna stay charged a little bit longer so we can see the LED turning on and discharging slowly, please. So 0.7 volt. Oh, we have 2 volt. Time to plug. Ooh, did you saw that was a little fainted light. .17 volt. Now we're gonna plug it and you're gonna see clearly the LED turning on and probably off pretty quickly. Yep. So today I learned a lot of stuff concerning charging capacitor with piezoelectric disc. It's gonna be really better with the 1N4004 standard diode. It's gonna be better with these than the fast switching diode. I would have to check like the spec of the fast switching diode and I could explain it, but currently I don't have the spec sheet, so I don't really know what's the differences, but there are plenty of other differences. And it's easier to charge a small value capacitor, but it will just discharge faster. That was a really nice experiment, but you know, I didn't create any of this because in the 90s it was popularized to put these kind of circuit into your shoes and you were charging a battery and your shoes would be able to produce light having a rechargeable battery. So I hope you enjoyed that little simple experience. I think I'm pretty done with piezo for like a month or so, and we're going to do some other stuff later, and see you next time.